Howdy, AP PreCal, it's Miss Kosh. I have gone through the beginning of the AP PreCal curriculum and reworked how I want to teach it. So I have videos from last year, and I'm also going to make videos for Mr. Passwater's notes, but we're going to do it piece by piece, and this is the way that I want to teach this material. So it's pretty exciting. After seeing the course, after going through it for a year, I have a better sense of where we're going. So I'm excited about that. And so let's jump right in. I'm kind of teaching 1-1, 1-2, 1-3 kind of swirled together. So it may not exactly match up, but it made sense to me, and that's what we have to go with. Okay, so a function is a mathematical relation that maps a set of input values to a set of output values, such that each input value is mapped to exactly one output value. Okay, so for every input, there is exactly one output. That doesn't mean that every output has exactly one input. We'll talk about that later. And it doesn't mean that there has to be, it can be a function even if it doesn't, if there's a number that I can have in the input that doesn't have an output. That didn't help. For example, what I was thinking was something like, if you have the square root function, it's only defined from 0 to infinity, okay? So just because it doesn't have something at x equals -5 doesn't mean it's not a function. Okay, I digress. Okay, the set of input values is called the domain of the function. The variable representing input values is called the independent. And I can't spell, so there we go. The set of output values is called the range, and the variable representing the output values is called the dependent variable. Dependent, okay, maybe I can't spell, anyway. Okay, so historically you've always looked at, you've done a vertical line test, and while that isn't entirely false, it's not going to be the best thing. First of all, AP will expect us to talk about input and output values. And we saw this on the AP exam when we start talking about inverses. And so just saying it failed a horizontal line test isn't enough. You needed to talk about input and output values. And then also, the other reason that that's not sufficient is that we will study functions later that would fail a vertical line test. In particular, if you're curious, you can look up polar functions. Okay, so we like to express things graphically, numerically, analytically, and verbally. So I put this together and said, tell me, is it a function? And so graphically, is this one a function? Yes. Every input value has exactly one output value. So that would be our justification here. So this one was yes, and you're gonna have to work off of what I just said verbally. The next one, we have this numerical arrangement of things. We've got even our x and our y values, and we have, so what I'm gonna look for to see if this is a function is, does every input value, do they repeat? Oh, so what I notice is that there's a 3 here and a 3 there, and they map onto 2 different output values. So no, this would not be a function because the input value of 3 has 2 different output values, and so therefore it's a relation, but it's not a function. Okay, the next one, here's analytically, so they've given us a piecewise function. Notice it's defined, well, it's actually not defined at -2, but it's defined anything bigger than -2 to 4. It includes 4 on this piece, but then it goes from 4 to 6 over here. So we've got what I recognize is that we've got a quadratic and then a linear function, and so those are both functions, and it doesn't have, one way that we could make this not a function would be to, well, if I made this an equal sign instead of, if I said this was 4 is less than or equal to x, then we would be defined at 2 different places, and unless they're the same value, let's see, if I plug in 4, I get -16 plus 4, I get -12, I get 12, I get different values. Okay, so that would, this as it's written, yes, it is a function. How could I change that? It would not be a function if this were a less than or equal to sign, if it looked like this. It would also, if I had something like f of x equals, and I did like a plus or minus square root of x or whatever, this plus or minus, so square root of x looks like this, and negative looks like that. And so this would have your x that you plug in would get a positive and a negative output value. And so this would not be a function. So that would be another way where in the equation you could tell it's not a function. We'll talk more about this as we keep going. Okay, verbally, sometimes our problems are described verbally. And it says water is being added to a tub. W of t represents the height of the water after t minutes. And so at every particular time, if you could freeze time for just a second, you could measure the height of that water, and there would be a particular one value. And so yes, this is a function, every input value of time. So your input would be time, your domain is time. Your range, the height, the output of height, there's exactly one height at every time. Okay, let's keep going.